Spooky season is upon us. Ready to make your very own Halloween-themed memory match game? With phasereditor v4, we're turning your ideas into an exciting game. By using the editor to create our game visually, and with a little bit of code, we can create awesome games like this. By the end of this video, you'll have mastered key game development techniques like how to create reusable game objects with prefabs, how to use script nodes for dynamic animations. We'll see how we can seamlessly integrate our existing JavaScript code with the phasereditor v4, setting up click events and having game objects react to them, building and linking new scenes for our gameplay flow. Finally, we'll add some spooky audio to enhance the atmosphere for our game. If you are interested in following along with this video, you'll need to have access to the 4th version of the Phaser editor. In this video, we won't be covering how to download and install the editor, and so for more details on how to do this, please see the documentation on the Phaser website. There will also be a link in the description of this video to the Phaser editor. One more thing to note is having experience with the Phaser editor is beneficial, but it's not a requirement for this video. We won't be going over the basics of the Phaser editor in this video, but if you are interested in learning more, I do have a crash course video that shows how you can get started with Phaser editor. In that video, we go over all of the basics, so how to set up your projects, the various tools and the UIs and what they do, and it shows you how to create very simple games by using the various built-in visual editors to create your Phaser game objects. So if you are interested in learning more, I do recommend checking out that video. It'll be linked in the screen now, as well as in the description of this video. Please note this tutorial is tailored for phasereditor v4. If you're using a newer version, some features may look slightly different, but the core concepts will still apply. Alright, so grab your Halloween candy and let's dive into this Halloween memory match game. Open your phasereditor v4 and let's bring your spooky ideas to life. To start building our game, first we need to create a new project inside phasereditor. From the Getting Starting page, click on the New Project button. Once you do this, you'll be presented with some of the built-in project templates. For our game, we'll be using the basic JavaScript template. So if we choose that now we can choose where we'd like to save our game. In the modal that appears, create a new folder. We'll call this Phaser Halloween Memory Match. Once we create our folder, click Open to go ahead and open up our folder. This will now open up our project inside the Phaser editor UI. From the Welcome page, we can click Open a Scene to go ahead and open up one of the existing scenes for our template. Another option is down here from Files, we can go to Source. Under the Scenes folder, this will have our 2 pre-existing scenes. Let's open up the level.scene file inside the editor, and we'll see our Getting Started template page here. So to run our game locally and to test our changes, we're going to rely on the Phaser editor to launch a web dev server for us locally that allows us to test our code. Up in the top left corner, if you click the play button here, this will allow us to run our project in the browser. This should open up a new browser window or tab, and we should see our Phaser 3 game based on the template we selected. If I click on the dyno, our text should be updated. And so if we go ahead and go into our browser developer tools, go into our console, we should see the Phaser banner with which version of Phaser we're currently running. So now, if we make changes to our scene here, we should be able to see those changes over in our browser. So for example, if I just drag this game object over a little bit, I save, I come back here, we reload, we'll see our scene is updated with where we placed our game object visually. Next, we'll need to add in the assets we'll be using for our game. In the description of this video, there'll be a link to this web page here, as well as a link to a direct download for our game assets zip folder. You can click that link now to download the assets. You'll need to extract the assets from the zip folder, and once you do, you should see the following assets in that folder. So inside this asset folder, we're going to have our audio, our images, and some additional scripts that we'll be using for our game. And so this will be for things like our background, our sprite sheet for our cards and our card images, and different things like that. Our scripts, we'll get more into it later, but these will be reusable scripts we'll be using for our game. Finally, there's a project task to-do list, which will list all the steps we need to complete to create our game. Once you have those assets, now we need to add them into our project. To do this, let's go ahead and choose Assets, and then from here, we can go ahead and drag and drop our assets that we'd like to add to our game, or we can do Browse to add our files. So for this, we'll just drag over our folders. So we'll do Audio, come back to Assets, let's do Images, and then we want to go ahead and do our project task list. So what we'll do is under our root folder, let's just add in a project task list. Then under our source folder, this is where we'll want to grab our scripts folder. So now we've added our assets to our project, now we need to tell Phaser editor that we like to use them for our game. So from our audio, we'll go ahead and choose import as audio to add it to our asset pack entry. We'll want to choose our assets assetpack.json file for all of our assets. Next, we need to do the same thing for our images. Let's click on our background or full screen images. We'll do import as image. Next, do our sprite sheet JSON and sprite sheet PNG. These we want to import as an atlas. Go ahead and add those to our asset pack. Then finally, inside our text, let's do our 4 images here and do import as image. Finally, for our scripts that we added, we do not need to add those to our asset pack. So once we finish doing this, we should see a variety of images show up in our blocks here for the images that we added to our game, and we should see our atlas of our sprite sheet with our various card images that we'll be using. With our project now set up and we've loaded in our assets, it's now time to start working on our title scene. So for our title scene of our game, we're just going to have a very few simple game objects with some simple animations. So we'll have a few text game objects for our memory match title here, as well as this click to play, and then we'll have our background image. When the scene first starts, we'll have our text animate onto our screen, and then when we listen for a click event, we'll be able to navigate to our level scene. We'll actually have our gameplay. Later on, we'll add in support for full screen, and so we'll have a button to toggle full screen from our various scenes in our game. To get started with our title scene, we need to create a new scene and add it to our project. To do this, we'll come down to our scenes folder. Let's do right click, we're going to do new, and we'll do new scene file. For our scene name, we're just going to call this title, and let's do create. Now this will create a new phaser scene for us. And so we'll have our title.scene and our title.js file. Next, to use our scene in our game, we need to update our game configuration to use this scene. So under our source folder, let's open up main.js. So inside main.js, there's going to be a bunch of boilerplate code for our phaser game. And this is the code that was generated as part of the initial template when we use that for bootstrapping our project. What the template currently does is it references our other phaser scenes that have already been created, our level and preload scenes. It adds those to our phaser game configuration, and then it launches our game once the browser is ready. To use our new scene, we need to add that code here. So at the top of our file, let's copy our import statement for preload. We're going to do import title from scenes, and we want to reference title.js. Then down here, we need to add that scene to our configuration. So we'll copy this line, we'll do game scene.add, and then we'll update our scene key to be title. And so this needs to be unique across our scenes so we can reference it properly. And now we need to reference our title class that was generated when we created our title scene here. So if we open up our title.js, we'll see we have a class that extends phaser.scene. And so we just need to pass this class to our game configuration, and the phaser will create a new instance of it for us. So this has added our scene to our configuration. If we want to actually connect it to one of our existing scenes, we need to do that in our code. So if we come to our preload.js file, we come down to the bottom of our code, we should see a create method. And what this method currently does is it starts our level scene. Instead of starting our level scene, we want to start our new title scene, and then we'll have that connect to our level scene. So to make testing a little bit easier, I'm just going to comment this out and leave it. Then later on, when we're working on our level, we'll add that back in, and we'll just toggle this on and off. So let's reference title, we'll save, come back to our browser. If we test our game, we should now see a blank screen after our preload scene. And that's because we have no game objects in our scene currently. Now we can create and add game objects to our scene. So if we jump over to the title.scene file in our editor, and what we can do now is we can drag and drop our various blocks to create our game objects in our scene. So if we take our background image block here, if we drag it onto our scene, we'll see now our new background image is added to our editor. If we go ahead and save, we come back to our game, we should see that our background is now visible to the player. So for our background object here, we actually want to make this reusable across our various scenes. So in our memory match game, we're going to use that same background for our title scene and for our game scene once our game actually starts. And so since we're reusing that game object, we're going to create a prefab of this. And by doing that, it's going to allow us to create multiple instances of our game object by using that one prefab. And so the prefab is kind of like a snapshot of our game object and the properties we set on it, and then we can create individual instances of that. And so this will be useful because our background is currently larger than our canvas element, and so we'll want to size this so it fits it more appropriately. And so we'll do things like modifying our position and our scale, and then that way we don't have to do it in both scenes, we only have to do it in one location. So I create a prefab. What I'm going to do is first let's update our name. I'm going to change this to be background, then we'll right click on our game object. Let's go into prefab and we'll do create prefab with object. Once we do this, the UI is going to ask us where we like to save our prefabs at. And so to keep our code organized, we're going to make a new subfolder for our prefab. So let's cancel out. We'll come to our source folder. Let's make a new folder. So we do right click, new, let's do folder. We're going to call this prefabs. And so for any prefabs we create for our project, we're going to place them inside here. And now let's right click back on our background. Let's do prefab, create prefab with object. So let's use our prefabs folder. And so for our name, we'll do background prefab. Click the create button. If we save, we'll see now our object here over on our outline has been updated to show it's now referencing a prefab, and it's a prefab instance of our background. Same thing over with our type here. So under our source folder, if we open up prefabs, we'll see now we have our background prefab here. So let's open up our background prefab scene, and we're going to modify our background image here, so then that way any changes we make will be reflected back in our title scene. So I'm going to close out a few of these files. So for our background image game object, the first thing to do is let's update our origin. We're going to change this to be 0, 0, so then that way it's in the top left-hand corner, and then that way our game object will be positioned in the top left corner of our canvas element by default. Next, we'll update our scaling, and so we'll change this to 0.72 for both our X and our Y. That way we can scale it down a little bit. Finally, we're just going to modify the positioning a little bit, so we'll do -7 for our X, and we'll do -28 for our Y, and that way it gives us a very nice view here for our image. If we choose save and jump back over to our title scene, we'll see that our game element has only been updated for part of our properties. And so by default, our positioning is unlocked, and then that's where our game object is now positioned here. What we want to do is if we click the lock icon, and so by clicking the lock icon, what this will do is PhaserEditor is now going to use our parent class, our prefab of our background, to set these values. And so anytime we want to override these, we just unclick this lock icon here, and we can update those properties, and PhaserEditor will generate code to override that. Before our background, we just want to use what's set in our prefab. Next, we need to add in our text that is for our title and our click to play text. So from our blocks, let's grab the title block here from our image game objects. We'll drag that into our scene. For our positioning, we'll update our X position to be 640, and we'll do 246 for our Y value. We'll leave our origin the same, and now we want to do our click to play text. So if we grab this text here, we'll drag that into our scene. For our positioning, we'll do the same X value, so we'll do 640, and we'll do 521 for our Y value. So if we save and take a look at our game, we should now see our background's been updated, and we have our two text elements. Finally, for our title scene, we need to connect this to our level scene now. To do this, we need to listen for a click event on our scene, and once that click event happens, we'll use that to transition to our next phaser scene. To do this, we're going to be making use of the scripts that we previously added when we loaded in our assets. Under our scripts folder, we have a lib folder, and so this is going to be a reusable memory match library that we can use for our memory match game. Our script nodes have a bunch of utility scripts that allow us to have reusable functionality in our game. And what we'll be doing with these script nodes is we'll be attaching these to our various game objects, our phaser scenes, and we'll be able to use those to do different things. As an example, we have this generic animation one that's going to allow us to create animations very quickly. We also have some for listening for click events on our scene at a global level, and then we can react to them. Finally, we have a couple of scripts for doing our scene transitions, and all these script nodes do is this is just reusable JavaScript code that we've put into a separate file that we can now attach to other game objects. So this is one of the powerful features of PhaserEditor is these script nodes allow us to have this reusable functionality that we don't have to code every single time for our project, and we don't have to code manually. And it allows you to add functionality to your game without coding. So for us to transition to our level scene, we need to go ahead and add the script node here for our scene click event handler. So if we choose our scene here, let's drag and drop our scene click event handler scene into our scene. And so this will create an instance of our script node. And so real quick, if we open up our scene click handler.js file, so this JS file just has very small snippets of JavaScript code, and this is where script nodes are very powerful, is by keeping our script node very small, it makes it very usable across all of our projects. So all this script node is doing is once our scene starts, we register an event listener for the pointer down event. Besides that, the only other thing we added is we have this variable auto execute that allows us to control if we want this code to run automatically or to have it only run when it's invoked. And what this script is going to do is we can now chain it with other scripts to get other functionality from our click event. And so let's jump over to our title scene. From our instance of our scene click event handler, we need to unlock our auto execute and we want this to be true. So by default, our prefab has this variable auto execute, and it's normally set to false. And so if we want to override that, we need to click our lock icon and then choose our checkbox. So when we do this, nothing's going to happen in our scene. Now we need to direct that click to another script. And so for our script, we want to actually do a scene transition. And so we'll be making use of our start scene script node here. So if we click our scene click event handler, now if we drag and drop our start scene script node here, it'll be a child of that instance. And so one thing to note is if it is in the wrong position, you can right click and do layout, and you can do sort to move it up and down where it is in this hierarchy. And you can also do parent, and then you can do move to parent. And so you can nest it under our scene click event handler here. So by nesting this script node under our other script node, when we run our scene click event handler, what it's doing is it's calling this execute children. And so what execute children does, it allows us to execute our game objects or our script nodes that are childs of this current game object inside our phaser editor. And so once we do our scene click event handler, it's going to run, and then that's going to invoke our start scene. So for our start scene script node, all this does is it runs the logic for starting our phaser scene. So for this, we need to provide a scene name that we'd like to launch. And so we want to launch our level. So now if we do save, if we come back to our browser, let's refresh our game. So we'll see our title scene. And now if we click, we automatically transition over to our level scene. So as we can see, by using script nodes, it allows us to create reusable functionality in our code, and then we can use them in games where we don't actually have to write any code. We can just do this drag and drop interface to run that functionality. And so script nodes are very powerful, and you can do much more with them, and we'll see more about this once we do our animations in our game. But for now, we're going to stop working on our title scene since we have our basic layout in place, and now we'll start building out our actual level. To make it easier to test our changes while we're building out our level, we're going to update our game configuration to point to our level scene instead of our title scene. So under our source scenes folder, open up preload.js. Inside here, we're going to comment out the code where we transition to our title scene, and then let's uncomment the code where we start our level. So now when our game loads, it'll jump right to our level scene and we don't have to click on our title scene. Next, jump over to the level.scene file in our editor, and we're going to clean up our game objects that are currently exist here. So let's remove our dinosaur, let's remove our text. Then we need to go into our level.js file. So anytime we make changes to our .scene files inside the GUI, Phaser Editor is going to compile our code into the .js version of those files. When that code's generated, there's some areas that are automatically generated by the editor, and you should not place code there because it'll get overridden. And then there's certain areas that's marked where it's safe for you to add your own custom code. So as part of this project template, there was custom code added for when our scene is created to listen for that pointer down event on that dinosaur game object. Since we removed that, we can safely remove this code. Otherwise, what will happen is if we try to test our code, we'll see an error in our browser since we're trying to reference variables that do not exist. So we'll want to go ahead and save. If we refresh our browser, we'll see now after our preload scene, we jump right back to our level scene. For our level, first we need to add in our background. So from our blocks, let's drag in our prefab for our background onto our scene. Let's lock our position, so that way it's positioned in the same position as our title scene. Next up for our level scene, we need to create our card game objects that we'll be using for our memory match game. Since we'll be creating multiple instances of our card game objects, it makes sense to create these as a prefab because we'll have custom logic that we need to apply to each one, and then we can apply that in one place. To create our prefab, under our source folder, under prefabs, let's do new. Let's do a new prefab file. And for our name, we'll call this card prefab. So now if we drag over one of our image game objects, that will be the base for our prefab. So under our atlas, from our sprite sheet, if we expand it, we want to use the verse, so the back of our card image, and we'll drag that into our scene. We'll update our default position to be 0, 0, and we'll leave our origin set to 0.5 where it's at. So from our editor, let's open up our card prefab.js file. So we'll see for our prefab, we're extending our phaser game objects image. So for our card prefab class, we need to add some additional properties to our class, so then that way when we create instances of our card, we can have our objects be configurable. So for our card, we're going to need to keep track of what texture is currently applied to our card for when we flip our card over. And so we'll need to know what the front and the back images of our card needs to be. And so to add these properties, we could do these directly inside our class here. However, if we want them to be exposed in our UI so we can do the drag and drop interface for setting those values, we need to do it through here. So to add those values, what we do is under the prefab properties here, in the expector, we can choose add property, and this is going to give us a list of various property types we can use for our game object. What we're looking for is we want to use the texture config property. Now when this property is created, and so what this will do, this will now add our new property under our prefab properties, and we can see inside our UI here under what properties are available. So for our property name, so this will be the variable name that gets generated in our code. We'll call this card front texture config. For our label, this will be the display that's shown in the UI here. We'll just go ahead and use the same text, but we'll go ahead and space it out. So we'll do card front texture config. And then the tooltip is what's shown to us when we hover over this property. So we're just going to say the asset key to use for the front of the card. For our type, we'll have texture config, and now we can choose a default value if we like. So for the front of our cards, we're going to leave this blank since we want this to be dynamic based on what the card actually is. For our card back, this we will set to the default value of what we currently use for our texture. So if we choose save, if we jump over to our card prefab.js file, we'll see now our new property has been added to our class as part of the code that's auto-generated. And if we jump over to our level scene, from our prefabs, let's drag over our card here. And what we'll see is under our card prefab, we now have that property exposed to us, so now we can modify it. Let's jump back over to our card prefab scene. We want to add another property here, and this is also going to be a texture config property. This, we want to do card back texture config. So I'm just going to jump between the two of these so we can copy these values since they're mostly the same. And we'll save for the back of the card. Now for this one, we do want to use a default texture. So if we open up our folder here, it's going to show us the available textures in our game so far. And we'll choose our atlas and we'll use our verse or background texture here. So this is going to generate an object that has a key of sprite sheet. So this references our sprite sheet that we added to our game. And then frame is the individual frame of that sprite sheet. All right, so if we choose save, jump back over to card prefab, now we have a new property, card back texture config, and it's set to that object that we specified here. For our card prefab, we need to give the player an ability to click on that game object, and when that happens, we want to play an animation to have our card flip over to the other side, and then we'll need to be able to flip it back as well. So to support clicking on our individual game objects, we need to click on our actual image game object itself, and then from the editor under the inspector, we have this option called hit area. So for our shape, this will allow us to define the shape that will be used for when we listen for our events on our game object. And what this will do is by default, it's going to use the size of our game object for our dimensions, and so the dimensions of our image. And that works for our game, so we'll do save. Back in our card prefab.js file, what this will do is going to enable our game object to make it interactive, and that's what allows the phaser framework to emit events when players interact with our game object. Now all this does is this just enables it for input, and now we need to listen for that pointer down event on our game object and do something with it. So instead of using a script node for this, just to see another option of where we can manually generate code and have it work together with the UI, we're going to add some code to our custom class here. So what I'm going to do is under the scripts folder, we'll do script nodes. I'm going to open up our scene click handler.js file. I'm going to copy this block of code here, jump back to our card prefab, and now in our constructor where we can write our code, I'm going to go ahead and paste that in. Then I'm going to update this. So instead of being this.scene.input.once, we're going to do this.on. What this does, this references the instance of our game object, and the on method allows us to register that event listener for a given event, and we want our pointer down event. One thing to note is on allows us to listen for that event multiple times. In our scene click handler, we listen for once because we only want this to fire one time. And then instead of doing execute children, I'm just going to add a console log here so we can just make sure our logic's working, and we'll say click. So now if we save, if we jump back to our browser, let's refresh, we should see our card. If we click on it, we can see in our developer console that we have our click event is working how we expect it to. To create our card flip animation, this will be composed of a couple different phaser tweens. And so in Phaser, a tween is a way for us to create simple animations by modifying the properties on our game object. For our card object, we're going to end up scaling our X property to 0, so then that way our object's going to appear to shrink in place or have it appear to be flipping over and it's like standing on its edge. And then we'll scale our card back in the other direction, so then that way it looks like our card is now flipping over on the other side. By using these tweens, we can create this really cool effect by just modifying our game object properties, and that way we get this 2D animation. To create this animation, we'll also add some additional code to our card prefab class. Since we're going to be using multiple tweens, and we want the ability to flip our card over back and forth multiple times, we want to be able to reuse this, and so we'll be using what's called a timeline. And a timeline is a way for us to orchestrate our tweens and other events in Phaser based on running events at certain time, and allows us to also use tweens as part of this. So to create our timeline, first, let's add a new property to our class. And so we're going to call this flip timeline. And so this won't have a default value. Then up in our constructor, we'll do this.flip.timeline. We're going to set it equal to this. We're going to reference the scene that our game object is currently in. We'll use the add method, and then we're going to do timeline to create a timeline game object. So for our timeline game object, we can provide an array of events that we want to fire at given times. For our first event, this will be a tween. So now for our tween configuration, we need to provide our target. It's going to be this, so this instance of our game object. Now for the properties we want to modify, we're going to do our scale X and our scale Y. So we'll have scale X. I'm going to set that to 0, scale Y. We'll set this to 1.2. And next we'll have our duration. We're going to do 100 milliseconds. And our ease, we're going to use phaser.math.easing, and we'll do linear. In our configuration here, we're targeting our scale X and scale Y properties, and that's going to allow us to scale our X and Y individually instead of just doing the normal scale. By setting our X to 0, it's going to make it look like our card is shrinking or standing on its edge, and by setting it to Y, it's just going to make it a little bit bigger so it looks like it's coming up in the air, closer to the player. Our durations is how long that animation is going to last for, so 100 milliseconds can be very quick. And ease is the type of easing function we use for our tween. And by using linear, it's just going to use a constant value, so then that way our animation is just one smooth value. It won't be slow or fast towards the beginning or the end. Then next, now we need to add our tween for finishing our animation. Let's copy this. We'll go ahead and paste that here. Now we want to do the inverse. So our scale X, we're going to come back to 1. Our scale Y will come back to 1. We'll do the same duration, and we'll use the same easing function. Now that we have our timeline, we can remove our console log for our click event. And now if we do our flip timeline, if we do dot, and we're going to call the play method to play our animation. One last thing we're going to do is we're going to pass in true, and that's going to allow us to play our timeline from the beginning. So if it ever gets paused, we'll always start from the beginning. So if we choose save, let's come back to our browser, and we show the test. So if we click on our card, nothing happens. Yes, so for our tweens, we're running them actually at the same time. So when we have multiple tweens, we need to specify when our next tween will actually start. So by using the at property, we can now say that this tween will start at 100 milliseconds after the timeline begins. When we omit that, it'll start at 0. So previously they were both playing. Now if we do save, we come back. If we click our card, we get this nice card flip animation here. One last thing we need to do for our animation is now we need to show the front of our card when we flip it over. And so we'll need a property to keep track of if our card's actually flipped over or not. So I'm going to copy this here, go ahead and paste it, and we'll name our property. We'll do is flipped. And so for both these properties, we don't actually need these exposed in our UI. So by adding to our code directly, they won't actually be shown inside our card prefab UI here. So for our type, I'm just going to change this to be a Boolean. And we'll add a default value of false, so that way our card is not flipped over when the game begins. Now back up on our timeline, once we are in the middle of our animation, we need to update our card texture, so then that way we show the appropriate texture once it's visible to the player. So to do that, we need to add another configuration object. For this one, we want to target it at 100 milliseconds, so it runs the same time as our tween here. For this one, we're going to use the run property. What the run property allows us to do is we can provide custom code that we like to be invoked at this time. So now when this callback runs, we can use this set texture to update the texture that's currently applied to our game object. So this is where we'll need to reference the card front and the card back texture configs that we provided. So to figure out which one we need to use, we'll make a new variable, do const. We're just going to call this texture config. We're going to set it equal to this.isFlipped. So if our card is flipped over, if it's set to true, we want to use our card front texture config. Otherwise, we want to, if it's false, we'll do card back texture config. Now when we do set texture, we can reference our texture config. We'll use our key. Now we need to provide the frame. So we'll do texture config and we'll do frame. Then lastly, before we start our animation, we actually need to set that is flipped property. So up in our callback here for our pointer down event, we'll do this.isFlipped, and we'll set it equal to the opposite value. So we'll do this is flipped. Let's save. We've come back to the browser. All right, so if we save, let's refresh. We try to flip our card. Oh, we have an error. Yes, we're trying to reference a property on an object that does not exist. So back in our level scene, when we create an instance of our card, by default, our texture config is not currently set. And so now we need to provide a value for this. So let's unlock that. We'll choose our sprite sheet, and I'm going to choose this bat PNG here. We'll hit select. Let's save. Now our instance of our game object has the correct object. Let's test one more time. So now if we click our card, it flips over and it shows our bat. If we click it one more time, it goes back to the back, and we can do this multiple times. Now that we have our level set up and we have our overall layout for what we like our game to look like, we're going to start adding in our logic for the memory match game. For this, instead of placing all this code inside our level.js file, we'll be creating a new node script that'll have that logic, and then we can attach it to our scene and have it run when our game starts. So to do this, under our scripts folder, we'll do right click, we'll do new, and we'll do a new prefab file. So one thing to note about script nodes is they can also be prefabs. However, instead of using a root game object like an image or a text game object, we can use a script node for our base, and it still works like a prefab and becomes reusable. So for our naming, instead of using prefab, we're going to call this gameplay. So once we save, we'll have a new gameplay scene. For our starting object, from our blocks, we'll want to use script, and then we'll drag in a script node. Then we'll go ahead and save. So let's open up our gameplay.js. So our script node class has a couple of built-in methods that we'll be making use of for our gameplay script. One of these is the awake method. This method will be invoked automatically once our scene starts up and it starts running and we're able to run code in our script nodes. So instead of placing code we want to run right away in our constructor, we need to place that inside our awake method here. So this is where we can do any type of setup that we want for our game, and we start listening for events. So just to see an example, let's do a console log and do awake. We'll do save. We come to our level scene, we need to drag in an instance of our gameplay script. So we'll drag this into our scene, we'll save. Let's come to our browser. Let's open up our developer tools. So in our browser's console, we refresh our scene. We'll see now our awake method is being called from our gameplay script. Next, we need to start adding in our actual logic for the game of memory match. So the game of memory match is pretty simple. Primarily what we need to do is keep track of which cards have been flipped, and so we need to keep track of those indexes. Once the player has flipped over 2 cards, we need to check to see if they're equal. And so if this is a match here, we'd want to lock down our cards here so the player can't flip them back over again. And now it's considered a match. If the player flips over 2 cards that do not match, we'd want to flip those 2 cards back over, and that way the player can reselect them and try to remember where they're at. Now this pattern would continue until the player finds all the matches in the game, and then our game would be over and the player could play again. And so for our game, we won't be coding all this from scratch. We'll be making use of a reusable library that was included as part of the assets folder. So under the scripts folder, under lib, we have this memorymatch.js file and a memorymatch readme. So inside this file, there is a simple memory match class that has all of that logic that will do what I just described. And what's really nice about the reusable library is we can provide a set of callbacks that we like to be invoked when certain events happen in our game. And what these events are is when the player clicks on one of our cards, we'll update our internal state of what memory match should look like, and then a callback will be invoked. Then that way we can update our UI. So like when I click on this card here, we would be notified, hey, this card has now been flipped over, and in the UI we can flip it. Then once a match or mismatch is found, we'll be notified of that, and we can react to that in the UI as well. So for the library, it's constructed in a way where the only thing that's required is an array of cards, and so the cards can be anything. It could be numbers, strings, it could be objects, anything we'd like, and we need to provide that to memory match so we can play the game. And then we will call this flip card method to do that logic. Then we can provide these optional callbacks, and then that's going to allow us to do the logic that we like to do where we update our UI. So just to see an example of this, I'm going to copy this logic here from memory match. I'm going to come over to my browser developer console. I'm going to paste it in. Oh, we can't use the export keyword. Let's get rid of that. Let's copy it again. Clear. Paste it in. So now it'll be available in our browser. And then for memory match, I'm going to copy this logic here for creating our cards and our game. And so once we create our game instance, what we can do is we can take a look at what our cards actually look like. So if we do game, we'll do cards to get our cards. Now we'll see that our array was shuffled. And so we still have our same cards, but now they're in different places. Now what we can do is now we can try to flip our cards over. So if we call our flip card method, we'll see we flipped over the first index, will be this 2 here. And so if we try to do a card that's not a match, we're going to be notified that there's a mismatch, and we are also notified when a card was flipped over. So if we do a match, so if we do 0, and then we do index 2, that should be a match, and now we get notified the match is found. All right, and so that's just a high-level view of how the library works. So if you are interested in learning more, I do recommend checking out the source code. And if you do have questions or comments, or would like me to explain more in a future video, please let me know down in the comments down below. So now that we've seen how the memory match library works, we need to actually connect this to our game. So back over in our gameplay.js file, we need to create an instance of our memory match game. So at the top of our file, we'll need to import it in our library. So we're going to do import. We'll do memory match. We want to import this from, so our relative path is /, we'll have lib, and then we'll have memory match.js. Next, we need to create an instance of our memory match class. So above our awake method, let's add a property to keep track of this. So we'll do memory match. We'll have it be undefined. Now in our awake method, we're going to do this memory match will be equal to a new instance of memory match. Now we need to provide our game configuration. So first we have to do cards. And so we'll do an empty array for the time being. And let's do save. Let's come back over to our browser. If we refresh, we see that our code still runs and our awake method runs without any issue. So for our configuration, we need to provide an array of card objects that we want to pass. And to do this, we will update our gameplay scene. We'll add a new property to our prefab, and then that way we can pass in our cards from our level scene to our prefab here. So under our prefab properties, let's do add property. For our type, we want to do object variable property. Let's do add property. Now for our variable name, we'll call this cards. We'll do cards for our label, and we'll do list of card game objects. For our expression type, this will be the type that's added to our JS doc. And so we're going to do card prefab, and it'll be an array of them. For our default value, we'll just do an empty array, and now we'll save. So the object variable type allows us to pass other variable instances into our prefab. So see an example, if we come over to our level scene, let's open up our gameplay prefab. We'll see now under our prefab, we have the ability to now pass in additional objects. And how we set this up is we want to pass in a list of our card game objects. So when we select from here, we can see all of our objects that are currently in our scene are available to us, but we want to pass in more than one. And so we're not actually able to do that. To do that, we'll need to pass in an array. And one way we can do this from our game objects is we can use the list built-in method. So under our blocks, if we go into group, we can add in a list. And so this is one way we can create an array of objects that we want to pass around. So for our variable name, we're just going to call this cards. Now what we need to do is we need to add these cards to our list. So if we select all of our cards, we'll see one of our properties here on our inspector is list, and we can choose the available list variables that we've added. So if we do save, now all of our cards should be in this array. If we pop open our level.js file, what we should see in our code now is now we should have an array called cards. And so we do have our cards array here that reference all of our card game objects that we've been automatically created. And if we come down here, we'll see now we have our cards property, and that's where we set up our array. So now that we have our list of cards, we just need to update our card prefab here. We're going to grab a reference, and we're going to reference our cards array. All right, so let's save our scene, and let's jump back over to our gameplay.js file. So now that we have our cards, we can update our configuration to reference this .cards. Next, for our memory match configuration, we need to provide any callbacks that we like to use. Let's jump over to our memory match readme file. We're going to copy our configuration for our various callbacks here. We'll come back to our gameplay.js file, let's paste those in. Now for each of our properties, we're going to define a method on our class that'll be invoked when we want that callback to happen. So I'm going to copy all this logic here. I'm going to go ahead and paste it. Now for our method names, let's go ahead and change this so we can turn these into methods. So we'll just get rid of our arrow function. We'll keep our console log statements for the time being, and we'll get rid of our comma. And now we'll just do this for each of our other methods. Now that we have our methods on our class, we need to update our callbacks up here to invoke those methods. So we'll get rid of our console statements. We'll do this on card flip callback, pass on our card index, and we'll do the same for each of these. So we'll do this on match callback, We'll have our first index, second index. Let's copy that for our next line. We'll paste it. Do on mismatch callback. And then we'll have our callback for our game over. So we'll do this on game over callback. So two additional properties we're going to specify is we're going to specify a method for how we want to check for a match for our objects. So in the original example, we were just doing a simple check on numbers. And so we can use the default functionality of the library to check to see if two numbers are equal. Since we're going to have objects for our cards, we need a way to know if our two card objects are actually equal. And that's going to be based on the texture that we specify for our card. So to set that special function, we need to pass in a property for how to do that check. And so to do that, we need to do how to check, and then we're going to receive two arguments in our callback. So I'm just going to copy this here from our README. We'll come over to our gameplay. I'm going to paste that in. Let's change our bracket to our property. And this was TypeScript, so we'll get rid of our type. Now for our callback, we'll want to call another new method. And so we'll do this. Check for match. We'll have our first card and we'll have our second card. Let's create that new method. So we'll have check for match. We'll have first card, second card, and we'll leave that empty for the time being. One other property we want to specify is this how to shuffle method. So once we finish adding in our logic, we're going to allow the library to shuffle our cards for us, but while we're testing, we want to keep our array in the same position it's currently at. Otherwise, we need to update our game objects. And I want to focus on getting our gameplay logic working, and then we'll worry about the shuffle functionality after. So for how to shuffle, let's come back to our gameplay. Let's add in that property. So we'll have how to shuffle, and this will be an array that's going to receive the cards array. Now for this, we're just going to leave our callback empty. We're not going to do anything. And what this is going to result in is our cards are going to not be shuffled. Basically, we're going to get our cards array, and because we're not modifying it, that original array, since we're passing by reference, will stay in the same order it was in before. And so to see an example of this, I'm just going to add a console log statement, and we'll reference our memory match, and then we're going to reference the cards on our memory match game instance. Come over to our browser, if we save and refresh, we'll see our array of our card prefabs. If we take a look, we'll see our card front image will be bat. Our next one should be bat as well, since we didn't modify our array. If we omit this property here and we do the same test, what is likely to happen is our first index is now a different card, and then our next index is also a different card. And so we'll need logic to rearrange our cards after we do our shuffling, but we won't worry about that for now. So now that we have our configuration in place for our memory match game, we need to add in our actual logic we want to use for our various callbacks. We'll start with our check for match. And so for our check for match, when we get our two card prefabs, we just want to check the frames that are currently visible, and then that way we know the two game objects are equal. To do that, we're going to reference our first card. We're going to reference our card front texture config. And so this is one of the properties in our card prefab. And now we want to reference the frame of that object. Now we just want to see if it's equal to our second card instance. Let's copy this, we'll paste it, and we'll change this to be second card. So next up, we have our on-card flip callback. When this callback is invoked, it's when we need to actually play our animation for flipping our card over. To do that, we'll need to reference the card by its index in our array, and then call a method on our prefab. So we don't have this method yet, so we'll need to add that. So let's do this. We'll reference our cards. Let's reference our index. And now we want to call a method, so we're going to call this flip. So to add this method, let's jump over to our prefab JS file. Currently, we have our flip being controlled when we click on one of our game objects. Instead, we're going to want to move this logic here to a new method that'll be invoked. So let's copy that and remove it. Let's come down to here where we can add in our custom code. We'll add in a new method called flip. And now this will flip our cards over. If we jump back to our gameplay.js file, let's move to our next method, onMatch callback. So when there's matches, we won't do anything. We'll just do our console log statement for the time being. But later on, this could be used for like playing audio effects. When there's a successful match, we could maybe display like a text message to the player and things like that. So now on our onMismatch callback, we'll want to flip our cards back over. So then that way the player will be able to choose those cards again. Now to do this, we want to leave our cards face up just for a little period of time before we automatically flip them over. So we're going to use a delayed call to then flip our cards over. And so to do that, we'll reference this. We're going to reference our phaser scene that our script node belongs to. We'll use time, and we're going to do delayed call. For our delayed call, we can specify how long we want to wait. We'll wait 1 second, so 1,000 milliseconds. And now in our callback, so after we wait, we want to flip our cards over. So let's copy this line of code here where we do our card flip. Now we just want to change this to be first index. We'll copy that line, we'll paste it one more time, and we want to do our second index. That way we flip those two cards over. Finally, on our on game over callback, we'll just leave our console log for the time being where we log that our game is over. So one last change we need to do before we can test our code is we need a way for our gameplay script to be notified when the player clicks on one of our card prefabs. So there's a few different ways we could do this. We could pass in an instance of our gameplay script to our card prefab, and then that way when the player clicks on our card prefab, we would just invoke a method on our gameplay script. Another way is we can emit events to allow our components to communicate together. And what we can do is when we click on our card, we can emit an event that any object in our scene can listen for and then react to it. And what's really powerful about this is when we click on one of our cards, we could then use that event to flip our card over, to invoke our library. We could play an audio sound effect when a card flips, like a swoosh. We could maybe have like a little glitter effect once it gets flipped over, and different things like that. And by using an event, it allows us to easily extend our game without having that tight coupling. So now to do this, we want to emit this event so that way any object in our scene can listen for it. So we'll want to use our scene's event emitter. To do that, we'll use this. We'll reference our scene that our prefab instance belongs to. This will be our level scene. And now we can reference our events property to reference that event emitter. And next we'll do emit. And now we specify which event we want to send out. And so we'll do a custom event. We're just going to call this card clicked. And so when we emit our event, we also have the option to pass additional data. And so we're going to pass in our reference to this prefab instance that was clicked. So now back in our gameplay.js file, we can listen for that event. So in our awake method, we want to listen for an event on our scene. So we're going to reference this. We'll reference scene that our gameplay script is in. We'll reference the event emitter. And now we want to use the on method to be notified. And we'll do card clicked. And we'll receive our card instance. And now that we have our card, we'll do console.log. We'll do card. So if we come over to our browser, if we click on one of our card game objects, now we get a reference to that card prefab. So the last thing we need to do with our event listener is now we need to reference our memory match class, and now we need to call our flip card method. So we'll do this.memory match, we'll do flip card. And so what this means is on our card prefab instance, we'll need to know where that's at in our cards array. For that property, we're going to use the name field on our game objects, which allows us to set anything we like there. And by setting our name equal to our index of where that card's located, we'll be able to reference that property here. So when we call card flip, we'll do card.name to reference that name property. And so to update our card name, we'll need to loop through our cards array. So let's get rid of our console log here. We'll do this. We're going to reference our cards array. Now for each card, and we'll also have our index. And so here we'll reference our card object, we'll use the name property, and we're going to set it equal to the index. All right, so what we're doing here is when we do our for each loop, we receive which index of where we're at in our array, and we're just setting that to our name property. All right, so if we save our changes, let's come over to our browser. Let's refresh, and we should be able to test. If we click on two of our cards, this should be a match. Oh, looks like we have an issue, mismatch. Let's come back to our code. So if we check our how to check for match, yes, so we're calling our method here, but we're not actually returning the value from this function here. So we need to return the value from this call. Let's save, come back to our browser, try again. So now when we click our two bats, we'll see our match is found. If we try two cards that do not match, we see mismatch and they flip back over. And so just to test our logic, let's find all of our matches. And now our callback for our game over should be called. Nice. So now that we have our basic logic working for our game, we want to update our game so then that way we actually shuffle our cards when our game starts. So by default, this is built into our library, but we're overriding that. So let's get rid of our how to shuffle here. And now what we need to do is after we shuffle our cards, we're going to need to update the positions of our game objects based on where they're at in our cards array after it's shuffled. To do that, let's create a brand new method, and we'll call that at the bottom of our awake method. Let's call a new method. We'll call this deal cards. And then later on, we'll also use this for adding in our animations. Now for our method, let's add in deal cards. And so what we'll need to do is now we'll need to loop through all of our cards in our array after it's been shuffled and update their position. And since we're already looping through our array one time, let's copy that logic where we update our card's name. We're going to move that to deal cards. Now inside this loop here, this is where we'll do our updates. All right, so in our loop, we need to figure out what the X and Y value of our card should now be located at. To do this, we'll need to use our card's index after it's been shuffled and figure out our X and Y value based on which row and column our card needs to be added to. And so to do this, we're gonna add some code and then we'll come back and walk through what it does. So first, let's make a variable. We'll do const, we'll do row. We're gonna set equal to math.floor. And then we'll do our index. We're gonna divide it by 4. Next, we'll do our columns. We'll do column is going to equal our index, and then we'll do %4, and so that's going to get the remainder when we do our division. And now we need to figure out X and Y value from this. So we'll have const X is going to be equal to 160 plus our column value times 320. Now for our Y, we'll do const Y is going to be equal to 120 plus our row, and we'll times that by 240. So now that we have our X and Y values, we need to update our position. So we're going to call this, so we'll call card, we'll do set position, and we'll set our X and Y value. So now if we save, we come back to our browser. If we flip over one of our cards, we'll see which card was flipped. If we double check, we should see our texture is referenced our cat. We flip this one over, and we should see it's referencing our candle. Perfect. So what we ended up doing in our code was to figure out X and Y values. First, we want to take our index and convert that to a 2D coordinate. So our cards are currently set up as a 1D array. And to convert this to a 2D array, so that way we have rows and columns, so we can use that for our positioning, all we need to do is whichever index we're looking at, we just need to divide that by the number of columns we have. And then whatever that integer is and whatever that remainder is, that's going to be which row and column we want to add it to. So as an example, for index 0 here, we divide it by 4, our integer would be 0, so we know we're going to be in row 0, so this row here. Our remainder is actually 0, and so we know our column is 0. Versus this card over here, when we take our index of 2, we divide that by 4, we don't have any whole numbers, so it'll be 0. And then we have 2 left over, so 0, 1, 2. It's going to put us in this column here. If we take a look at this card, this will be index 7. So we have our index 7. If we divide it by 4, that gives us 1. So that's going to give us the correct row. And 7 divided by 4 is going to give us the remainder of 3. And that's going to give us our correct index for our column. And so by doing that simple division based on that number of columns, that's going to give us that row and column. From there, to convert it to an X and Y value, we just need to know our starting position and then offset it based on how far we're moving over. So in our example for our X, we started at 160 pixels and 120 for our Y. So we start here for positioning our game objects. And then we just add in 320 pixels times the number of columns, or 240 for the number of rows we're moving over. So as our rows and index increase, we'll have a further value go this way and a further value come down. Alright, so those last changes, that actually wraps up our core gameplay. And so as we saw, we can actually play a full game of our memory match game, and now we want to switch focus to working on our game polish. And so now this is where we'll be adding some nice animations for like dealing our cards. We'll add text when the game is over, allow the player to restart the game, and just really fine tune it so it looks really nice. And to get us started, we're going to keep working on our level scene, and we're going to start by having our cards come out on our scene and be animated in. And then we'll deal them out to their positions. So to get started with our dealing animation, we need to take all of our cards and have them appear off screen, and then we'll animate them on. And what we're going to end up doing is in our level scene, instead of doing each of our cards one by one and having animation for each card, we're going to group them together, so then that way we can create one animation and then move them all at the same time. And so to do this, we're going to use a container game object. So in our blocks, if we go to built-in group and we drag in a container, now let's go ahead and update our name. We'll do card container. So the container game object is going to allow us to place all of our other game objects inside it, and then we can just move that parent container, and it's going to move all those game objects that are its children, and they'll be positioned relative to our container. And so to do this, we need to take all of our card game objects. We need to make our container our parent. So if we right click and we do parent, we'll do move to parent. Let's choose our card container. Now that our cards are inside our card container, we want them to all be positioned in the same position so we can animate them together. To do that, let's go over to our inspector. We'll update our X and Y values to be 0, 0. And now they're all going to be positioned where our card container is. For our card container, we'll want this to be in the center of our screen so we know what position we need to move our container to. So let's do layout. We're going to do align to border. Let's do border center. Now we'll do that one more time, but we'll do layout, align to border, and let's do border middle, and that's going to position it right in the center. And so we see our card game objects container is set at 640 by 360. So when we do our animation, that's where we want to end up placing our container. Now that we have a container game object, we need to update our gameplay scene to be aware of it. So let's add a new prefab property. For our type, we're going to do an object so we can pass in our game object. Let's call this card container. We'll do card container for our label. Now for our tooltip, we'll say the container game object that has all of our cards. For our expression type, we'll leave this as game object. Let's go ahead and save. Jump back over to level scene. We'll go to our prefab instance, and let's reference our container game objects. We can pass it in. Now that we've passed that to our gameplay scene, we can reference it in our gameplay.js file. So in our deal cards method, we'll want to update our container so it starts off our screen. So we'll reference our card container. We're going to use the setY method, and for our position, we'll do 1000 pixels so it's off our screen. And now we want to animate it from that 1000 back to its original position. So for our animation, we'll be using another tween. So let's reference our scene. We'll do tweens, we'll do add, and now we need to do our configuration for our tween. So for our configuration, our target will be our card container. Our Y value, we want to go back to our 360. Our duration is going to be 1 second or 1000 milliseconds. We'll do ease. Let's do phaser, math, easing, sine, and we'll do in and out. That's just going to give us a nice smooth animation. And we'll do on complete. And what this property does is it allows us to provide a callback we want to be invoked once our animation is finished. Once our animation is done, now we want to update the positions of our cards to be in the correct position. So let's go ahead and save. If we jump over to the browser, we'll see our cards come on, and then they're automatically dealt out. However, they're not in the position that we expect them to be in. And what's happening is our card container is positioned here in the center of our screen, and all of our objects positions are positioned relative to that. So even though for our X and Y value, we're only doing 160 by 120, it's also adding in that X and Y value here to give us that new position. So if we want our game objects to be positioned where they were before, we'll need to either remove our game objects from our container, or we'll need to offset our X and Y value. And so we'll be doing the latter here. So if we're doing our offset, we just want to offset wherever our container is currently at. And so this is going to be 640. We'll want to subtract for our X, and we'll want to subtract 360 for our Y. And so that's just our X and Y position of our container here. So if we save, we'll jump back to our browser, cards come out, and now they pop into place. So for the next part of our animation, we want to deal our cards out one by one instead of having them all jump at one time. So for that, instead of calling set position, we're just going to do another tween, and we'll get a nice animation. But instead of placing another tween inside here, our code's going to get very large. We'll make a new method, and we'll just call that new method. So for this, we're going to call this move card. So in our method, we'll need to know what card game object we want the animation to be for. We'll need to know X and Y so we know where to place that card. And then lastly, we'll need our index of that card. So for our tween, let's copy this. We'll go ahead and paste it. Now we update our references. So instead of card container for our target, we just want to use our card. For our Y value, we'll pass in our Y. We'll also do our X. Our duration, we're going to do a lot smaller, so we'll do 200 milliseconds. We'll keep the same ease. We don't need on complete. Now, one other property we're going to add in is going to be a delay. And so for our delay, we're going to do 200 milliseconds, and we're going to times it by our index. And so what this is going to have the effect of doing is as we're dealing at our cards, as we get further in our array, we're going to wait longer before we trigger that animation. And so this is going to allow us to deal out one card at a time, versus if we don't do our delay, they'll all get played at once. All right, and so before we test, we need to come up to our onComplete method here. Let's get rid of our set position. We need to call our new method. Let's pass in card, we'll pass in X, Y, and our index. So if we save, and now we test, our cards will come to our center, and then we deal them out one by one, and we have this very nice animation. Alright, so the next thing we'll want to do is we're going to add some safeguards while we're doing our animation, so we can actually click on our cards. So right now, when our cards are being dealt, we can click on them, and we get a bunch of errors in our console, and some of our cards will be flipped over. And what's happening is we don't actually set our card's name and their position until after our first animation is complete. And so we're going to go ahead and lock our input until all of our animations are done. And then that way we have that nice safeguard and we'll control that input. To do this, let's add a new property to our class. So right after memory match, let's do lock input. We're going to set it equal to true by default. So then we'll come down to our wake method, and just to be safe, we'll do lock input. We're going to set equal to true. So that way, anytime a wiki is called, we'll reset it. Then in our event listener for our card clicked, let's get rid of our console log, and we're going to add a safeguard. So we'll do this. If our input is locked, we're just going to return early, so we don't actually do our logic for clicking. Then down in our deal cards, we'll want to wait until all of our animations are done before we unlock our input. So for this, we'll use a delayed call, and we'll go ahead and unlock our input after that amount of time. So let's reference our scene. Let's do time. We'll do delayed call. For our delayed call, let's do 3 seconds. We'll do 3000 milliseconds. Inside our callback, we're just going to do this. We'll do lock input. We'll set equal to false. So for our locking input, we'll also do that in a few other locations. So when we have a mismatch, we're going to go ahead and lock our input and wait for our animations to finish before we unlock it. Then that way, our player can't be flipping the cards back and forth when we're trying to animate them back over to the backside. So if we come to our onMismatch method, outside our delayed call here, let's lock our input. We'll set that equal to true. And then after we flip our cards over, let's unlock our input. So we're going to set this equal to false. So to make sure our game's still functioning, let's save. We'll come back to our browser. Now if we try clicking while our cards are being dealt, we can't actually click them. And then once they're finished, now we have our cards. And so when we have our mismatches, we can't actually click on them either. So next up, for our polish items, we're going to add some text to our game once it's over. And then we're going to add some animations, so then that way it will float onto our screen. And then we'll have the option to restart our game. So to add in our game over text, let's jump over to our level scene. Let's come down to our assets. And so under our images, we have some text that we like to use. Let's drag over our nice text image game object. For this, we'll want to position it in the center of our screen. So let's do 640 for our X. We'll do 360 for our Y. Oh, and this got placed inside our card container. So let's update our parents. If we do right click, let's do move to parent. We're going to bring it into our scene. And now let's update our position one more time. Do 640 by 360. Next, let's add our click to play again text. So we'll drag that onto our scene. And then so for this text, we're going to want it to animate into our scene like this. So what we'll do is let's place it outside our scene. So for our text, let's update our X and Y value. So for X, let's do 640 so it's centered. Now for our Y, we'll do 830. And we'll go ahead and save. So if we come back to our browser, if we save, we should see our text image game object here for our nice. And now what we need to do is once the game is actually over, this is when we'll have it show up on our scene, and then we'll have it be animated. So let's go ahead and start with our animations, and we'll start with our click to play again text. So for our animations, we'll be making use of our script nodes that we added as part of our assets. And so let's right click on our image game object up here. Let's do scripting. We'll do add script. Under our script nodes, let's do this animation config base. All right, so for our animation config base prefab instances, let's open up our animation config base.js file. So this script node prefab, All it's doing is it's just creating an instance of our tween configuration, and then we're playing that tween. So very similar to the code we've been adding manually in our gameplay scene where we create our animations for dealing out our cards, now we're doing it through a script node. And what the script node allows us to do is for all of our various properties, we can pass in those for our tween configuration, and then it configures it for us automatically. And what that'll allow us to do is when we create our animation config base instance of our prefab, now we have those properties on our UI. And so we don't have to manually code out all these animations. Instead, we can use this script node to do it for us. So for this animation, we're going to want to update our Y value to have our text appear here up on our screen. And so our to and from values, this is the values that we want to set for our Y. So where we're animating it to and what value we're coming from. So we're currently at 830 for our Y value. And we want to animate it to 628 for our Y value. For our duration, we'll stay with 1 second. Repeat, we don't want this to repeat, so we'll leave it at 0. And now for our property, we need to specify which property we want to do our tween on, and we want to do our Y. So for testing our changes, we're going to turn on auto execute. And what this will do is once our scene starts, it's going to invoke our script. And so we can see our animation. We'll keep our defaults of U and ease. And now for our delay, let's add in 2 seconds. We'll do 2000 milliseconds. And let's save. So if we come over to our browser, let's refresh. And we should see after 2 seconds, our text should now show up on our screen. All right, so since we verified our animation, let's turn off auto execute. And so we'll just lock our property again. Now we want to add our animations for our nice text. So for our text, we're going to want to have our text be scaled in. And so it's going to start off very small, then grow to be the size it is currently. And so to create that effect, we need to update our scale property on our text game object so it actually starts at 0. And then that way it's not visible to the player. And then so for our animation, we'll be updating our scale property to have it scale in. So let's add a new script. So if we do scripting, we'll do add script. We'll add in another animation config base. And so for our properties, we're going to do 1.2. Our duration, we're going to do 2 seconds. And for our property, we want to do scale. And by doing scale, that's going to set both our X and Y values. And let's do auto execute so we can see it show up on our screen. All right, so when we save, our text should now animate onto our screen when our game starts. All right, so once our text is animated onto our scene, we want to be able to allow the player to click the scene. And when they do, this is going to trigger the animations to have our text fly out. And it's going to allow them to restart the scene so they can play the game again. So to create this functionality, we need to do like what we did in our title scene, where we can enable our scene for our click event handler. And so for our script that we just added, let's add a child script to this. And so we're going to do scripting, add script. Let's do our scene click handler. So for this script, we don't want to enable auto execute because what's going to happen is after our animation is complete, it's going to call the execute method on this script here. And this will add our event listener for our click event. Now, once the player clicks, we want that to be our trigger to do more animations. And so for these, we'll want our text to animate off our screen to the top, and then this text will animate down to the bottom. So we'll need to add some more script nodes. So let's do right click. So let's right click. Let's add another script. Let's do our animation config base. We'll start with our nice text. And so now we're going to animate it straight up the top of our screen. So for our to value, we're going to go to -100. So it goes to the top. From, we'll start at our current position. It's going to be 360. Our duration, we'll do 800 milliseconds. And for our property, we want to do Y. And for this, we're going to specify a target game object. And we're going to choose our nice text. Now, if we click back on this script, let's add another script. So we'll do scripting, add script. Let's do another animation config base. For this one, we're going to do our click to play again text. So let's choose our target. For our to and from, we're going to do 1200 for our Y. From, we're going to come from our initial position of 628. Our duration will also do 800 milliseconds. And then finally, we'll also animate our cards out of our scene as well. So let's add in one more script. We'll do another animation. For this one, our target will be our card container, so we can move all of our cards at one time. Now for to and from, let's do 1200. We'll do 360. Duration, we'll leave it 1 second. Our property, we need to do Y. And we'll save. And then finally, the last thing we need to do is actually restart our scene. So once our animation completes for our cards, let's add in one more script node. For this one, we want to do scene restart. We'll add our script, and let's go ahead and save. So if we come to our browser, we should be able to test our scripts end to end. And actually, let's auto execute our click to play again animation as well, so we can see our full animation working together. So if we refresh our scene, we'll see our text comes in. Now this one floats in after. Now our game is over, so if we click, now our text flies off, but our click to play did not. So let's take a look at our logic. So we have our click to play text. Yes, we didn't set our property. Let's set Y. Let's save, and we'll test one more time. All right, so our text comes in, our other text comes in. We click, and everything flies off the screen, and then we restart our scene. All right, so since we verified it's working, let's turn off auto execute, so then that way we can trigger these when our game is actually over. So to do that, we need to pass the script nodes that we want to execute when our game is over. To do this, we're going to add another list game object so we can add our script nodes to it that we want to invoke. So from here, let's drag over a new list object. For our list, let's call this game over script nodes. Now let's choose our child, our root child, for both of our game objects. And then for our list, let's choose our new list, and we'll save. So what this will allow us to do is now we can manually call that execute method, and then these will trigger their children if they have any. So if we jump over to our gameplay scene, now we need to inform our gameplay script about our new list. So let's add a property. We'll do an object property. So let's call this game over script nodes. We'll do game over script nodes. And we'll do game over script nodes to execute. So for this is going to be a script node array. For our default value, let's do an empty array. So now if we come into our script, let's go to where our game is over. So we'll go into our callback. And now we just want to iterate over that array. And for each of those script nodes, we need to execute them. So let's do this. We'll do our game over script nodes. We'll do for each. So for each script node, we'll do script node. We'll call the execute method. And we'll go ahead and save. So one last change I'm going to make before we test is I'm going to come back to our configuration for our memory game, and I'm going to add back in our property where we can have a custom how to shuffle method. And so by doing that, it'll allow us to quickly test our game. So we'll do how to shuffle. For this, we'll receive our cards array. And so in our callback, we won't actually do anything. So we'll just keep our array in the same position. So now if we come into our browser, we should be able to quickly test. We'll let our cards get dealt out. Now all of our matches should be right next to each other. So we can just quickly click on our cards. Oh, and it looks like a game is not over. Yes. Back in our level scene, when we added a new property to our gameplay scene, we didn't actually pass it into our prefab instance. So if we come to our level scene, we'll grab our gameplay. We need to actually pass in our list, so we actually have our scripts that we need to call. Now let's save. We'll test one more time. We'll let our cards come out. And we'll find our matches. So now our game is over. We get our text. And if we click, nice. All right, so now that our level scene's looking really nice with our animations, we're going to jump back to our title scene. And right now our text is very static, so we're going to add some nice animations to this as well, so it gets a really nice effect when our game starts up. So to access our title scene, we'll need to come back to our preload scene and actually update our code so we jump into our scene for our title. So let's uncomment that code. We'll comment out our level scene. Now if we come back to our browser, our title scene should start up. Now we want to use our script nodes to create the animations here. All right, so for our title text, we're going to do similar to what we did to our level scene. We're going to have it scale in, and so we'll have it start off where it is not visible to the player, and then we'll scale it in to the size it's currently at. So let's go ahead and update our X and Y scale values to be 0. And then let's add a new script node. So we'll do scripting, we'll add script. Let's add in our animation one. So to get us started, we'll do our to and from values. So for 2, we want to animate to 1, we'll come from 0. For our duration, we're going to do 2 seconds. For our property, let's do scale. And for the rest of our properties, we'll leave as the default. Once that is done, we're going to have our text actually animate up and down a little bit, so it looks like it's kind of floating. So to do that, let's add in another script node. So we'll do scripting as script. So for our to value, we'll do 226, and we'll do 246 for our from. We'll keep our duration where it's at. For repeat, we're going to do -1. And so this is going to allow this animation to repeat indefinitely until we manually stop it. And now we need to do our property. Let's do Y. And for one more property, let's do yo-yo. And what yo-yo is going to allow us to do is it's going to allow us to animate to one of our values, and then it's going to animate back to the original value before it repeats. And so it's going to give us a really smooth animation as it goes up, then down, then up, then down. Otherwise, it would kind of jump. It would go up and then jump back down to where it was automatically and then repeat that. And so it's not very smooth, and yo-yo will do that for us automatically. And so one last change we need to do is in our first script, our child script, our parent script, we want to go ahead and turn on auto execute because when our title scene starts, we want to play these automatically. So let's jump up to our click to play. And for this, we want this to fade in. So instead of animating from the bottom of our screen up, we're going to create a nice fade effect. So let's add in our script node. So we'll do scripting, add script, add our animation. And so for having our game object fade in, we'll be modifying our alpha property. And so your alpha property will be a value between 0 and 1. So we're going to animate it to 1 so it's fully visible. And we're going to start off not at 0 but at 0.2 so it's a little bit visible and it's going to show to the player. Now for this, we're going to want this to be a fade effect that keeps playing. So we'll also do -1 to have it repeat. We need to do our alpha property. And we're going to do auto execute. And we're going to do yo-yo so we have that nice animation. Finally, we're going to add in a delay so it doesn't start right away when our game starts. It's going to wait a small period of time, so 1.5 seconds. So on our click to play game object, now we just want to update our alpha so it starts off at 0, and that way it's not visible. So if we save, let's come to our browser, we should be able to test. So now when our scene starts, our title text comes in and it floats, but our click to play automatically started. Let's jump back over here to our animation configuration. Our delay did not get saved. So we want to change that back. And now that we have our delay, much better. And so now if we click, we're taken into our level scene and our cards get dealt out. Alright, so with our nice animations added to our title and our level scene, we only have 2 small features left that we're going to add. And so we're just going to add some spooky background music for ambiance while the players play our game. And then we're going to add a full screen button, so then that way when they play, it can take up their whole browser, or if they're playing on mobile, it can take up their whole mobile screen. So to get started with our full screen button, what we'll do is we're going to add a new scene to our Phaser game, and this is going to be like a UI scene. Typically for UI elements, it's really nice to have a different scene running because you can run them in parallel, and that's going to allow us to have our UI elements placed on top of all of our other game objects, and they'll always be positioned in the same position, even when we transition across multiple scenes if we keep that scene running. We need to add a new scene to our game, so in our source folder under scenes, let's make a new scene. So we'll do new scene file, and we're just going to call this UI. So we create our scene. Alright, so for our UI scene, we need to drag in an instance of our full screen button. Oh, and it's showing under as an image block. Alright, so we don't want to use an image. Instead, we need to actually have this be a sprite sheet so we can select an individual frame. To do that, we need to fix our asset pack JSON. So if we open up our file, we'll see our full screen image was imported as an image. So we want to actually change this to be a sprite sheet. Alright, so if we right click, let's delete this from our asset pack JSON. We'll save. Now, if we go to our image and from our asset pack entry, we want to choose import as sprite sheet. So now if we click on our sprite sheet, we can set our frame width and height. And so we want to change this to be 64 by 64. All right, so once we do that, we can close our asset pack JSON. Back in our UI scene, now we should see under our blocks, we should see our sprite sheet. If we click, now we have our two sprites available to us. Let's drag in our sprite for 0 for our full screen button. And we're going to want to add custom code to this, so let's create a prefab. So if we right click on it, let's do prefab, and we'll do create prefab with object. So we'll want to save this in our prefabs, and we're going to call this full screen button prefab. So now under prefabs, let's open that up. And we'll also open up our JS file. So for our full screen button, we need to make it interactive so that way our player can actually click on it. So let's click on our game object. We need to define our hit area. Let's do a rectangle. We'll use our default size to use our whole frame width and height. Let's save. Come into our JS file, we should see set interactive is now set to true. All right, so for our full screen button, we need to actually listen for our events when the player clicks on it. And we don't want to listen for pointer down, we have to listen for pointer up, otherwise the browser can reject the request when we try to start full screen. So this is very important that we listen for the correct event. Once we listen for that event, then we can use the phaser methods for starting full screen and for stopping it when the player clicks on it a second time. So to add this logic, inside our constructor and the spot where we can actually add additional code, let's first listen for our event. So we'll do this, we'll do on to listen to our event emitter for our game object. Now we want to reference phaser, we're going to do input, we'll do events, we're going to do pointer up. And now we can register our callback to be invoked. So when this is called, we want to first check to see if the game's already full screen. So we're going to do if this scene.scale.is full screen, then we want to go ahead and stop running our full screen. So we'll do this scene.scale.stop full screen, and we'll return. If it's not already full screen, then we want to go ahead and start it. So I'm just going to copy this line of code here. We'll paste it here, and we'll do start full screen. All right, so one last change we're going to make for our button is we're just going to update our button's frame to reflect the state of our actual button. So with that, we can just call this logic here. So we're going to do this to reference our game object. We're going to do set frame to update our frame because it's on the same texture. And we'll use frame 1 when we start full screen, so we toggle it. And when we do stop full screen, we'll set this to 0. One other change we're going to do is when our game instance is created, we're just going to add code to check if it's already full screen or not, and then set our frame accordingly. So we're just going to add logic to check to see if we're already in full screen. So if we're already full screen, we'll want to show the appropriate frame. So we'll do frame 1, and we'll do else, and then we'll show frame 0. So now we have our button. Let's come back to our UI scene. So let's position this in our top left-hand corner. So let's do right click. We're going to do layout, align to border. We're going to do border right. We'll do right click layout, and we'll do border top. So we don't want it right on the edge. We're going to bump it over just a little bit. So instead of doing 32 for our Y, let's do 42. So we have our 10 for our padding. We'll also do that over here. So we'll do 1238. So let's save. And now we need to actually add our UI scene to our game configuration, and then we need to start it. So if we go into our main.js file, let's load in our new scene. And so we'll have our UI.js, and we'll have our UI. Come down to our configuration. Let's add in our scene. So we'll have UI. We'll reference our UI class. Now that we've added our scene to our configuration, we just need to launch our scene. So when we launch our scene, we just want to launch this after our title scene starts. So if we go into our title.js file, let's come to our create method, and after our editor create, we're going to launch our secondary scene. We're going to do this.scene, we'll do launch, and we're going to pass in UI for the scene we want to use. So if we save, and we come back to our browser, let's go ahead and refresh, and we should see our new full screen button show up in our game. So what scene.launch does, it allows us to start another phaser scene, and it's going to run it in parallel to any other scenes that are currently running. Versus if we call this scene.start, it's going to stop the current scene and start that one instead. So by using launch, now we can run both of these, and if we click on our button, we see now our game takes the full screen of our browser. and we can click on it without it affecting our title scene. And if we click in our title scene, now we have our cards show up, and we can still full screen and minimize our level. And just for a quick test, let's play our game. We'll see we get to the end. We click, we restart our scene, and our UI scene is still working how we want it to. Alright, so before we add our game audio, let's just do some code cleanup real quick. Let's jump over to our gameplay script. So we open up gameplay.js. I'm just going to comment out our console log statements for where we were testing before. And that way we're not sending all that to our browser console. And then finally, I'm going to remove that code for where we don't shuffle our array. So I'm just going to comment this out so we can still use it for testing. We'll save. Let's just refresh our game real quick. If we click, let's do a quick match. All right, nice. So the last feature we need to implement for our game is we're just going to add that background audio. So let's jump over to our UI scene, and we have a utility script to help us do this. So under our scripts or script nodes, there is a playaudio.js and playaudio.scene file. So if we open up playaudio.js, we can take a look at our code real quick. And so inside our script node, we're passing in two properties. One is the key for the audio we like to play, and the other one's for a loop, so we can loop our music if we like to. Then we're referencing the start method, and so this method is going to be invoked once we start our script. So once our scene actually starts and it's available, it's going to start playing our audio. And all we're doing inside here is we just have a safeguard to make sure we actually have a key, and if we do, then we start playing our audio, and we play it on our scene, and then we loop it based on that property. And so to add our audio, we just need to add the script node to our scene. So we'll drag up an instance of our playaudio.scene file into our scene. Now we just need to specify our audio key. So if we click our lock, we just want to choose our one audio file, so background, and we want this to loop. So we'll go ahead and do save. And now we should be able to test. So if we come over to our browser, let's restart our scene. We shouldn't hear our audio, but once we click anywhere in our browser, we should now hear our music. Alright, so with our last feature, that actually wraps up our Halloween memory match game that we built using the phasereditor. And so with this example project here, you could easily extend this to add other things like additional cards from the memory game. You could add in levels, scoring, and much, much more. So if you do end up extending this project, I would love to see it, and so please let me know in the comments down below. If you do have any questions on the content that was covered here, or have ideas or suggestions that you'd like to see other videos on, please let me know. And so with that, that actually brings this video to an end. So as a reminder, in the description of this video, there will be a link to the complete source code for this project. And as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video is released. For more great Phaser 3 content, please see some links on your screen now.